Cole Stanchina, quiet in the back. Thank you. Right. Chapter 8 review number 2. There's your shout out that you wanted. All right. Number 1, this is simplify, multiply, divide, add, subtract, whatever we are asking you to do, you need to be able to do. So in number 1, we started this whole unit with simplifying rational expressions. We talked about factoring the numerators, factoring the denominators. In this case right here for this one, we can factor the denominator, we can factor an x out. So when we do that, we're left with x over, factor an x out of there, x minus 6. Okay. Once you get this to be a factor, then it will be able to reduce. So remember, you can't just go crossing off terms. You have to actually factor it out before you can eliminate it. So now this is going to be x over x, which is just 1. So the final answer there is going to be 1 over x minus 6. Okay. Number 2, I'm going to go really fast here. So if you have a question, let me know. I'll pause it. Next question, same concept, but we have a little more action. So factor out a 3 in the top. I'm left with an x minus 6. Factor out a difference of squares in the bottom. I have x plus 6 times x minus 6. And here we will have a common binomial term, x minus 6, that will cancel out. And so our final answer here is 3 over x plus 6. Okay, next one we are adding. So now this is where we have to get common denominators. So the common denominator between 5x and x squared is going to be 5x squared. So the first stuff needs to be multiplied by x over x, and the second stuff, or the stuff on the right, needs to be multiplied by 5 over 5. That's going to give us common denominators. So now we're going to have 4x over 5x squared plus 25 over 5x squared. And now we are able to add the numerators. So remember, when you add fractions, you add the numerator stuff and you keep the denominator stuff the same. So this one will be 4x plus 25 over 5x squared. And I can't factor anything out of 4x plus 25, so I'm just stuck with that. Okay. Next question is a subtraction question. In order to find common denominators, we want to factor the denominator. So this is going to be x plus 2 times x minus 2, difference of squares. And you'll see that the common denominator will be essentially that denominator, x squared minus 4. And this one here needs to have an extra x minus 2 factor. So I'm going to multiply the top and bottom by that, and then I will have common denominators. So what's up, Staub? Staub's all amped up because he's in the state tournament this week. So he's hoping that all the students go and support the wrestling team.
You better not be here on Thursday. That's all it is. They do not want to be here.
What? Come on, Sean, let's go. Let's just take a quick survey. Who's planning on going on Thursday? Just a quick show of hands here. Oh, 4. What? Hey, take it easy. All right, so we got minus the numerator. This is going to be a problem area. So you minus 4x minus 8 here. Whoops. And you're going to have to not forget to distribute that minus to both these terms. So you got to be careful with minus, especially when you're subtracting more than a monomial, because you have to distribute the negative through. So hopefully I didn't make any mistakes here, but it looks like I have 2x squared minus 8 minus 4x. I'll write it all down here. 2x squared minus 8 minus 4x plus 32. Wait a minute, no, plus 8, dummy. I was thinking I had a 4 out there. It's hopping around on me now. All right, plus 8, correct? And that would all be over x squared minus 4. And then you can clean up that numerator a bit more so that you would have 2x squared minus 4x. Not correct, because these are going to cancel out. So we're going to have 2x squared minus 4x, which a 2 is going to factor, a 2 and an x is going to factor out of that. So really we would have 2x times x minus 2. Is that accurate? Oh, there could have been another way to do this then, because we could have reduced something right away. But I did not recognize that. So actually, when you are all said and done on this one, a common x minus 2 factors out. And so the final answer is just 2x over x plus 2. And so what I'm realizing now is I could have factored out up here a 2, and then I would have had x squared minus 4, and then see what happens there is that would have just been a 2, and I could have gone a little different way there, but either way you would get to the same result. Okay. This next one here is a little tricky. This happens to students all the time when you go from like add and subtract to multiply and divide. You do not need to get common denominators for this next one because it's a multiplication. So this is the one where you can simplify before you multiply. So I would factor out what I can, rewrite this in factored form, x times x plus 4 there, multiplied by, I got an x plus 4 over here, over an x. And once you get everything written in factored form and you're multiplying it, now I can reduce anything common factor in the numerator and denominator. So this one right here is going to be 5 over x times x is x squared. Okay, so simplify before you can multiply. All right. This next one here is what we call a complex fraction, and with all of the kind of interruptions to learning here with the snow days, we haven't really talked about this yet. But what does this dividing bar, what does this mean here? Like, whoop. What does this fraction bar really mean? What operation? It means divide, okay? So really this is the numerator divided by the denominator. But dividing is the same as multiplying by the reciprocal. So all this really is saying is take 8 over whatever this denominator is here, m squared plus m minus 2. Okay, so take that and divide it by 12 over m plus 2. So it's like a fraction divided by a fraction, but really dividing is the same as multiplying by the reciprocal. So I can take the numerator and divide it by the denominator, but ultimately we are going to be taking that, because how do you divide? How do you divide fractions? You multiply by the reciprocal, right? So I take the reciprocal of that stuff and I multiply it. And then this, I'm sure, will factor m plus 2 times m minus 1. And you will have a common factor of m plus 2 that will be eliminated before you multiply it. And a common factor here of 4. So that will be a 2 and that will be a 3. And so the final answer here on this one, all that's left in the top is 2 over what's left in the bottom is m minus 1 times 3. So you see a complex fraction like that, and all you need to do is rewrite it as a division and then rewrite it as a multiply by the reciprocal. It's really not too big of a deal. All right, the next thing we did was solve the rational equations, and the strategy we used is getting all the denominators to be the same, and then once you do that, you can ignore the denominators except for when you're checking for extraneous solutions. So common denominator between 2x and x would be 2x. So in this case, I'll multiply this middle fraction by 2 over 2, and that will give me 9 plus 14 equals 12x minus 1. And of course, all those would be over 2x now. And since they're all over 2x, you can just forget about them. And so if you forget about them, then you can solve the numerator stuff, and you can essentially eliminate having to deal with fractions in your equation. So now my solution for the numerator would be 25 is equal to 12x minus 1. Add the 1 over there, 12x equals what? 26. So x is 3. Don't forget, check for extraneous. Check to see if 3 makes any denominator 0. It doesn't, so we're okay with x equals 3 as our solution. Yep.
9 plus 14 is 23.
Oh, 23, dummy. Good. Yep, I do that on purpose just to make sure you guys know I'm human. So 23 plus that's 24, which makes this 2. Thanks, Tommy. Thanks, Tommy. I'm going to hook you up with a little candy for that. Shh, just kidding. That's illegal. I'm going to hook you up with a healthy snack. Okay, x over x is the same as 1. Then I get my common denominator, so I multiply that one by x. Oh, wait, but it's x squared, so I'm making mistakes left and right now. So let's backtrack there. Just rewound myself. Common denominator x squared. So this is going to be x squared over x squared. That's the same as 1. Multiply this by another x over x. So that's going to be a 2x, and the 15 stuff is good to go. So let's rewrite that as x squared over x squared plus 2x over x squared equals 15 over x squared. Okay, all the denominators are the same, so I can just solve the numerators. That's going to be a quadratic, so it's probably going to factor because it's a happy little math book problem. And we'll get a couple of solutions, and hopefully none of them are extraneous. Actually, hopefully there are. I think it's fun when we get extraneous. So we get x and x plus 5 minus 3 is how that factors, I believe. So now solutions are going to be negative 5 or positive 3. And do either one of those make any of the denominator stuff 0? Nope, so we're good. So both of those are legit solutions, no extraneous. Whew, all right, last question on this page. Well, my page actually. Common denominator between x plus 2, 3, and x plus 2. That's going to have to be the product of both of those. So we're going to multiply this one by 3 over 3. We're going to multiply this one by x plus 2 over x plus 2. It's kind of squishy in there. And we'll multiply this one here by 3 over 3. Okay, and I'll clean that all up. So the first stuff is going to be negative 2x times 3, which is negative 6x over 3 times x plus 2. Plus, the middle part's going to be a binomial x times x plus 2, so that's going to be x squared plus 2x over 3 times x plus 2. And I'm getting tight on room over here. The next one's going to be equals 4 times 3 is 12 over 3 times x plus 2. Okay, and the same concept applies. Solve the numerator stuff. So I'm going to set that all equal to 0 because it is a quadratic. So I have x squared minus 4x on the left, and then I move the 12 over and I get minus 12 equals 0. And then I'm going to get x and x and minus 6 plus 2. Ho-ho! All right, I see an x plus 2, so I'm seeing a little extraneous going to be in here. That's going to be a 6, or this is going to be a negative 2. But watch out, everybody, because negative 2 is going to make a denominator 0, so I'm not going to have that as part of my solution. That's extraneous. Extraneous. So this is the only one that works. Okay. All right, 14 minutes. Ta-da! That's 9 questions. I'll finish the rest here next hour. Okay. All right, I'm just jumping right in here. So some people are trickling in. It's a little bit of background noise, but anyway. If you're solving radical equations, let's get the radical by itself. So I'm going to divide both sides by 3. Okay, divide both sides by 3. Then I'm going to be left with the cube root of x plus 5. Okay, and that's going to equal 2. So how do I get rid of a cube root? Cube it. Cube both sides. So if I cube both sides, that will get rid of a cube root. So cube both sides there. I'm going to be left with x plus 5 on the left is equal to 8. And then I subtract 5 and I get x equals 3. And then I just need to make sure to check if it's anything's extraneous. And so it's not going to be equal to a negative, and it's a cube root, which could be anyway. So we are good on x equals 3 there. Okay. Okay, next one, similar question. How do I get rid of to the half power? Well, to the half power is the same as square root. So squared or anything to the inverse power or reciprocal power. So something that's a power to a reciprocal power cancels out. So like something to the half power to the squared power, power times the power you multiply, and the reciprocals times each other equal 1. So this is going to be x minus 5 squared over here, and then equal to 4x plus 1 to the first power, which I won't even write there. So squared cancels out a half power. FOIL this side out, x squared minus 10x plus 25 equals 4x plus 1. Quadratic, set it equal to 0, factor and solve. So x squared minus 14x plus 24 equals 0. And that's going to be a 12 and a 2. So x minus 12, x minus 2 equals 0. So we got 12 or 2. Check for extraneous solutions. And in this case, 2 is not going to work because when I put 2 in for that, it's going to be a negative 3, and the square root of 4x plus 1 is not going to equal a negative. The smallest that could be is 0. So that's extraneous. So the only one that works here is going to be 12. The next one, we have an inequality, and with an inequality we use test points, and the first point that we are going to put on our graph, I'm just going to write it over here right now, that like critical value is 0 because x cannot equal 0. So that has to be a open circle on my number line because I have a denominator that is x. So x cannot be 0. So that's one of the critical values. The other one is going to be what do I get when I solve it. So I'm going to do cross products here and do x times negative 14. So that's going to be negative 14x equals 1 times x plus 15. Subtract the x over, I get negative 15x equals 15, so x is negative 1. So now I have my two values, x is negative 1 and x is 0, and I put those on my number line. So I have an open circle at negative 1 because it is just strictly greater than, or less than, excuse me. And then I also have an open circle at 0 because that's a restricted domain value, so x cannot equal 0. Then I do my test points. In this case, I tested x equals 1, and I put a 1 in for x, and I got a 16 over 1 less than negative 14, and that is false, so it's false out here, so we're going to say it's true in here. So x is going to be greater than negative 1, less than 0. Those are all the values that would make that inequality true. Okay. All right, some hopefully quick ones here, going from exponent form to radical form. Remember, if you're going to rewrite an exponent as a radical, the denominator is the index of the root. So in this case, it's going to be the fifth root of x squared, just like that. Technically, you could also have the squared, let me ungroup this here. You can have the squared out here like this. There is no difference. It's the same exact value. It just sometimes it's better to square the number inside the radical. Sometimes it's just better not to. So either way, you can have either one of those is acceptable. So this next one here, we have a number value, so this might actually simplify. Cube root of 27 to the negative second power. So in this case, I think it's better to have it on the outside because I know the cube root of 27 is 3. So this is like the same as 3 to the negative second power. And 3 to the negative second power is the same as 1 over 3 to the positive second power, which is essentially 1/9. Essentially, yep. It's equivalent to 1/9. All right, going in the other direction, if you have radical form to exponent form, and the rule that we use is, if you have x to the, let's say it's m over n, that is the nth root of x to the m, or you can write it this way, the nth root of x to the m, like that. So the denominator is 4, so this is going to be the same as 5 to the 8 over 4, which is 5 squared, which is 25. So that's just another way of saying 25. Okay, the next one is on the outside, so this is going to be the same as x to the 3/5. Right, now we get into some simplifying. So we have a couple radicals. They're both fourth roots. Sometimes it's easier to multiply the stuff together. Sometimes it's easier to deal with it separately. You just have to go on a problem by problem basis. So in this case, I'm going to multiply them. So we have one radical, and I can do that because they're both fourth roots. So if they're both fourth roots, I can combine the radical stuff to be 20 times 8, which is 160, x to the 12th. And when I do that, I will have a perfect fourth root, x to the 12th. Other perfect fourth roots are 16. So 16 and 10. When I start to simplify this, and I go perfect fourth root stuff, not perfect fourth root stuff, perfect fourth root stuff would be like 16 x to the 12th, and then the other factor over here is just going to be non-perfect factor of 10. Right? So if I multiply these two things together, I get what I have up there. Except for the fourth root of 16 is 2, and the fourth root of 12 is x cubed. So that's 2x cubed, and then what I have left inside the root is fourth root of 10. Okay, the formatting on this next one got a little weird, but I think these are just x's, right? Yeah, so those are just x's. So if I'm going to multiply powers with the same base, how do I deal with the exponents? Do I add them? Do I multiply them? What do I do? I like to go back to this. X squared times x cubed. That's going to be x to the 5th. So I add them. All right. So if I forget, I try to go back to something simple to remember the rule. And so now I'm essentially adding 1/4 plus 5/6 plus 3/2. Right? So a common denominator between 4, 6, and 2 is 12. So I'm going to change these all into 12ths. So this is the same as x to the 3/12 plus 10/12 plus, that's 6, that's going to be 18/12. Okay, that's going to be 31/12. So x to the 31/12, right? And that is how many leftover 12ths if I divide it out? It's like 24, and then there's 7 left over, right? So this is like, you can also rewrite this as x to the 24/12 times x to the 7/12. But of course, x to the 24/12 is x squared, so this is like x squared, and then if you get crazy here, 12th root of x to the 7th. So, but I probably, would just take this. But if you're looking in the back of books or something, you might see something wild like that. Okay. So I don't want to get like super crazy about it. I just want you to be able to know that you have to add all of the exponents together when it's a power times a power. And if they're fractions, you have to deal with fractions. Okay. The next one is a cube root of a fraction. So when you have the cube root of a fraction, you can take the cube root of the numerator stuff and denominator stuff separately. So that's what I'll do here. Take the cube root of 3. The numerator, I think, is a perfect cube, isn't it? Because 4 times 4 times 4 is 64. So the numerator stuff ends up being a perfect cube that's 4x squared over, and then I have in the denominator cube root of 3. So I have to rationalize the cube root of 3 is the deal. So in order to rationalize that, I need to multiply it by the cube root of 3 squared. The reason why I need to multiply by the cube root of 3 squared is because I want the denominator to be the cube root of 3 cubed. Because if you look at 3 to the first times 3 to the second, I'm going to get what? 3 to the third. So instead of like writing them all out like I was doing earlier, I just wrote it in exponential form. Just a little cleaner. So now this one is going to be in the numerator stuff, 4x squared times the cube root of, I'm just going to say 9, over, and then in the denominator, jeepers, I'm just going to have a 3. Because the cube root of 3 cubed is a perfect cube, 3. Some people might be perplexed at what happened in the denominator, so I'll elaborate a little bit and say this is going to be the cube root of 3 cubed. And so the cube root of something cubed is just whatever the something is, right? If you're still perplexed, you can maybe think of it as, okay, well, that's the cube root of 27. How did I get 27? 3 times 3 times 3. And so the cube root of 27 is a perfect cube, 3. That's how I get rid of the radical in the denominator. So pretty wild stuff. Sometimes I stop and can't believe this is what I do for a living. All right, last part of this is more exponent properties with fractions. So 1/32 to the 1/5 power. 1/5 power is the same as what? Fifth root. So this is the fifth root of 1/32, and 32 is a perfect fifth root, so this is just a happy little 1/2. Half times a half times a half times a half times a half is a 32nd. Next one, we have power divided by a power. And so what you do when you have, let's just say we had y cubed over y squared, what would that be? Y to the first. So what you subtract the exponents. Okay, so in this case, I'm going to subtract 12/5 from 2/5. So it's y to the 2/5 minus 12/5. Okay, which ends up being y to the negative 10/5. And y to the negative 10/5 is the same as y to the negative second, which is the same as 1 over y squared. We are not in Kansas anymore. The next one, we have another radical of a quotient. So we have the cube root of, I'm going to break this up, negative 27 m to the 11th over cube root of m squared. Numerator stuff has the ability to simplify a little bit. So that's going to be negative 27 is a perfect cube, negative 3. So that's going to be negative 3 and then m cubed. And then what's left in there is the cube root of m squared. Okay. That's because if you look at this, this is going to break this up into perfect square stuff, not perfect cube stuff, not perfect cube stuff. So negative 27 is a perfect cube, and m to the 9th is a perfect cube. And then what's left in the non-perfect cube stuff is m squared. So you simplify that radical itself. So then this stuff right here becomes negative 3m squared, or cubed, excuse me. And then what's left in the radical is the cube root of m squared. So all of that is over the cube root of m squared. Oh, look at there. That's neat. The cube root of m squared stuff will just cancel out with that other stuff. Huh. All right, so we just have right here negative 3, and I should have realized that before. I was in tunnel vision mode. Negative 3m cubed is my answer. Now, if you go back in time, like they do in Wayne's World, diddly-oo, 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 and you look at the problem again from the start, what could I have done right from the get-go? I could have simplified the m's, right? Duh. Okay, but so I took the long way home. I took the long way home. Some of you are just like looking so forlorn. You'll be okay. Almost done. Got my favorite type of question in this chapter is the word problem. So here we have a couple. Ooh, a couple can paddle a canoe 9 miles down the Mississippi River. In the same amount of time, they can paddle 5 miles upstream. We did one like this before. Find the speed of the current if the speed of the canoe is 2 miles an hour in still water. So they are going different distances, right? But the time is the same. So it says in the same amount of time. And so time, when we set these up, was equal to distance over rate, right? So we have essentially distance over rate is equal to distance over rate. And one of these is going to be upstream, and one of them is going to be downstream. So we'll just say that's upstream, and that's gently down the stream. Okay, so upstream is going to be 5 miles an hour, or 5 miles. So I go 5 miles upstream, and I can go 2 miles an hour in still water, but I'm fighting the current, so that's going to be 2 minus c. I take the current away from my 2 miles I can paddle normally and with no current. Hopefully it's not more than 2 miles an hour, or I'd be going backwards down the river, right? And so that equals the 9 miles gently down the stream of 2 miles an hour in still water plus your current. And so C I'm defining as the current speed. And so now I can cross multiply on this one. So I can use my cross products, and I can solve this right up just like this. 9 times 2 minus c equals 5 times 2 plus c. Don't you see? 18 minus 9c equals 10 plus 5c. That's 14c on the right. And that is 8c on the left. Isn't that right? Oh, I just wanted to say c, I guess. Yeah, 8. Sorry, 8. So now c, no, it's not 18. I subtracted 10 though. All right, so now we have what? C is equal to 8/14, which is the same as 4/7. But no one ever says 4/7. They'd probably say like whatever it is as a decimal. But I'll say 4/7 because I'm a math teacher. C is equal to 4/7 miles per hour. 4/7 of a mile per hour. Ta-da! That is fun. Okay. 35 minutes. Holy crime in Italy. All right. So next one is a little review and transformations. And so we have here, I'll just move all the stuff over that doesn't belong. So let's say we got a y minus 2 equals the square root of x minus 3. We're not going to have any stretches or compressions on this one. This one is just going to move to the right 3. And this one's going to move up 2. And so I go right 3, up 2. There's my little special point. And then I just sketch a normal square root graph. What's up? Is the format off on the thing? Because there's that little square there. So question, trying to get a hint on the test. Good, try to get a hint. I honestly don't remember. I bet you, I just have an inkling it'll be like the word problem in here, but yeah. Okay, so the current ones are the ones you like. Yep, so there we go on that. This next one doesn't have any right or left, but it has a, now some of you like to move everything over, that's totally fine. So this would be a y plus 4 over there, and then that 3 is going to move over there as a divide, and that equals the square root of x, so there is no horizontal effect here. And so this is all going to be down 4, and this is a divide, so it is a vertical stretch. And so that's going to make it like a taller one, right? It's going to be a little taller. So it's going to go down 4, and it's going to have a vertical stretch. So it might be a little bit taller. Wish it was a little bit taller. All right, good job. Under 40 minutes. There you go. Good luck studying. So question was, a vertical stretch is tall and a vertical compression would be like, vertical stretch would be tall and a vertical compression would be like wider. Yeah. And honestly, the whole stretch compression like terminology like can be a little confusing sometimes. So let's just think about this for a minute, just in like kind of plain terms. If I multiply right there, so if I go, hey, y value is going to equal some stuff and then times it by 3, what's going to happen to that number? It's going to get bigger, right? So the y values are going to get bigger. So like normally in the parent function, if I put a 1 in, I get a 1 out, right? Well, now if I put a 1 in, I don't get a 1 out, I get a what out? I get a 3, so I'm up here. So yeah, so like, normal parent function might have been like that, but now this one now ends up being like that, right? It has like a taller effect, or it increases faster, like y goes up faster because you're timesing it by 3. Does that make sense? All right. Have a good night.